Alright guys, now we are going to move on to the second degree price discrimination. First of all, let us see what the definition tells us about it. Okay, the second degree price discrimination. Block pricing, it is just one part of it. We are going to see how the second degree price discrimination is divided into various types of it. Okay, so the firm charges different prices based on quantity consumed. It is often thought of as a bulk discounting. Firm captures some of the consumer surplus. Okay, buy two get one free offers. We are going to see more examples and more types of second degree price discrimination. Okay, so let us write first of all that this is the second one. Second degree price discrimination. All right, so you will see that these can be divided into various parts. First of all, the first part is block pricing. Okay, it is block pricing. The second one is the two-part tariff. The two-part tariff system. Okay, you will see numericals on each of these topics have been asked before, either in JAM, in GATE, or in CUET. Okay, somewhere or the other, these topics have been mentioned either in their theory or with a numerical. Numericals are mostly asked from the two-part tariff part. Okay, so in two-part tariff you will see that either there is a single consumer case, okay, or there is a optimum tariff, OI tariff, or a case where there are two two customers, two consumers. Okay, so we are going to start with block pricing. Let me use a different color. I'll use black. We start with block pricing. Okay, what is this block pricing? So let us see graphically what we are trying to say. Okay, we are going to be drawing a downward sloping demand curve and a horizontal MC for simplification. Okay, so first let us try to understand what this block pricing really means. Okay, when we are talking about block pricing, we are saying that we are dividing the market into blocks. Okay, there is market segmentation, and the monopolist is able to do so because he has perfect knowledge. Okay, so he has divided the market into different blocks and he is going to charge a constant price for each block. The prices are going to be different for each of the blocks, but inside that block price is going to be constant for various customers. Okay, let us say that for example, uh, when you go to Spotify, you will see that for all the customers the price is the same, but there is a specific block of people which is students, and for students the prices are different. Similarly, if you avail the railway services, okay, you will see that children have to pay a lesser amount of money, right? Elderly have to pay a lesser amount of money, but the people that come within the working age population, they have to pay a higher fare. Okay, so what has been done here? The government has divided people into different blocks based on their age, right? So based on any category, may it be income, may it be age, right, or whatever, the monopolist is dividing his customer base into different blocks and each block is being charged a different price. Let us see what we are talking about graphically. Let us say we talk about this price, right? We know this is price, this is quantity. So this price is being charged for these people. Okay, for Q star people or Q1 people, P1 price is being charged for the first block, right? Let us now talk about the second block. This is Q2. Okay, so these many people are being charged P2, right? Q2 minus Q1 people are being charged the price P2, which means this block, this block of people are being charged this price. Similarly, let us say this block is being charged at Q3 minus Q2 quantity, they are being charged P3. Okay, so the monopolist has divided his entire market base into three blocks, and each of the blocks are being charged different prices. So do you see any consumer surplus here? Right, because that will be the only way that this is different from the first degree price discrimination. We are going to draw that in blue. Let us see. In the first case, you can see that the maximum willingness to pay was at this point, but the price that the whole block is paying is P1. Okay, it is P1. So this very small triangle, I know it is very small, but still there is some consumer surplus is still there. Why? Because each of the customer is not being charged at their maximum willingness to pay. The blocks have an average price, right? This block, this block has an average price of P1. So there are some people in this block who want to pay lower. Some are there who can pay higher, who value the good at a higher price, but they are also being charged the price P1. Okay, so there is going to be still some consumer surplus left. Similarly, for the second block, this is going to be their consumer surplus. Similarly, for the third block who are being charged P3, this is going to be their consumer surplus. So you will see that there is relatively lower consumer surplus from a normal monopoly type of market, but there is higher consumer surplus from the first degree price discrimination. Okay, right? So we can write all of these points down, that first of all, the monopolist has divided the market into various blocks such that each block is being charged a constant price which differs among various blocks, right? Secondly, there is some consumer surplus left, unlike the first degree price discrimination. Okay, so these are some points to keep in mind. Now let us look at this from another angle. Let us talk about block pricing only, but from a different angle. Let us talk about it numerically. You saw that the first quantity that was being charged, that was being consumed at the highest price level P1 was Q1. Similarly, the second one was Q2. But a there is a small twist that you might have noticed, or you may have missed also. When we were consuming at the price P1, the quantity that we were consuming was Q1. But when we were consuming at price P2, the quantity that we were consuming was not Q2, because Q2 is this whole thing. Our block told us, the size of our block told us what we are consuming is Q2 minus Q1, only this much, right? So how can we write this numerically? We can write Q1, or let us write in small letters. Q1 is available at price P1. Q2 minus Q1 is available at P2. How do you think? Can we write our profit? First of all, we are going to talk about the total revenue, which is the first part of profit. So our total revenue will be P1 into Q1 plus P2 into Q2 minus Q1. This is your total revenue, right? This block and then this block, right? Lower price, but only this much, which is Q2 minus Q1. And then comes the cost. What is going to be the cost? It will be just marginal cost into which of these quantities? You don't have to write these, like you don't have to multiply cost to each of these individually. The whole of these quantity is just nothing but Q2, right? Because Q1 plus Q2 minus Q1 is just Q2, this whole part. So we can just write this as CQ2, right? This is the entire profit function that we have here. Okay, this is the formula for block pricing. So I will give you a question for homework that you have to solve using this very formula. So your price function is given. This is your demand function basically. That okay, it is the same for both. So Pi is equal to 10 minus Qi. So when it is for the demand function of the first good, it will be P1 is equal to 10 minus Q1. Similarly, P2 is equal to 10 minus Q2. There are two goods in the market. Okay. So you have to solve this. Okay. So what you are going to do is just let me tell you. You will first of all calculate the profit function in terms of Q1, Q2 and C1 and C into Q1 and Q2. However you solve it, keep this formula in mind. That is all you have to do. Then after you have written down the profit function, you have to differentiate that first of all with respect to Q1. You are going to take out the partial derivative. Okay. Then you are going to find Q1 in terms of Q2. Similarly, you are going to do the same with Q2. Okay, and then you are going to be finding two different functions. Okay, you are going to be finding two different functions. You are going to using both of these to find Q1 star and Q2 star, and your answer is going to be in terms of C. Your answer should be in terms of C. Let me give you the answer. Okay, you can cross check your answer. Q2 star is going to be 10 minus C by 3. Q1 star is going to be 10 minus C by 3. They are both going to be equal. Okay. This is just for you to cross check. Now let us move on to the next part. The next part as we have already seen is it is the two-part tariff. And in the two-part tariff, first of all, we are going to do the single consumer tariff. Okay, the single consumer tariff. Now, first of all, just let me write the formula for this. Okay, what does the two-part tariff really mean? The two-part tariff, the formula for this is consumer surplus plus price into quantity. We are going to see the explanation for this very soon. So now what we are going to do is we are going to be looking at the different methods under the two-part tariff. When there is a single consumer, the tariff paid is going to be the same. Okay, this is going to be the, let us write it like this. It is going to be consumer surplus plus price into quantity. Okay, this part is also called the marginal price, and obviously this, you know, that this is nothing but the consumer surplus. So what is the step by step process going to be to find the complete tariff. Okay, let us see. First of all, I'm just going to write it down, then we are going to take an example. Graphically, this case is going to be very similar to the first degree price discrimination. Okay, if you take constant MC or marginal cost, okay, this is going to be your AR or your demand curve. So in this case also, the equilibrium point is going to be at price is equal to MC. Okay, and there is going to be no deadweight loss because there is only one consumer. We are going to be maximizing his entire consumer surplus and we are going to be extracting all of it as our profit. Okay, so this is going to be nothing but our profit. Okay, so there is going to be no deadweight loss here. Now one thing that I think I did not mention, that in the block pricing part, is there space here? No, you can just write it here. In block pricing you can add something, that in block pricing the monopolist or the you can write there can be dead weight loss. Okay, now it is not necessary. For example, in the example that we took, there was no dead weight loss, but there can be an example, let's say like there can be a graph something like this, where this is there, and this part is the dead weight loss. Okay, when the monopolist does not equate his lowest price to the MC, then there can be deadweight loss. Suppose that the lowest price that the monopolist charged was P2 and he did not go below that. Okay, then what will be this? This is a missed quantity, this is a missed market, so this is going to be the deadweight loss in that case. Okay, so you can just write that it is possible to have deadweight loss in block pricing. Okay, but right now we are in the single consumer case and we will not have any deadweight loss because right now we are equating price to marginal cost. Okay, this is the equilibrium condition here. Otherwise, you know that the real condition for equilibrium in monopoly is MR is equal to MC, and here you can see that AR and MR are the same because there is a single consumer and we are extracting all of his consumer surplus. Okay, so now let us take an example. So we are just going to, let us take that on a new page. I'll write down the question first. So your question is that you are given quantity, a relationship between quantity and price, which is 24 minus P. You are given marginal cost as 6. Okay, very simple. So what was the first step? The first step was to write down the equilibrium condition, and from that you can get Q. So you know that P is nothing but 24 minus Q, right? We took Q to the other side. So this is equal to 6. So Q star is equal to 18, and from this you can also get P star. P star is 6. Okay, right? So you can just draw a graph for more clarity, that we have a constant MC. The MC is already given in the question itself, which is at 6, right? This is P, this is Q, and our maximum quantity, the or the equilibrium quantity is at 18. Okay, so we can also just quickly take 0. So if P is 0, Q is 24. If Q is 0, uh, if Q is 0, P is 24. Okay, so the maximum values are both 24. So this is so that we can draw the demand curve. Okay, and this is the point where we have 18. This is the equilibrium points. So the equilibrium price is also 6, the marginal cost is also 6. Okay, now let us move on. This was the first step. Now when we move on, you are going to see that we can calculate the consumer surplus. Consumer surplus is what we have already seen this part, because the entire consumer surplus is being extracted as the profit. So the consumer surplus was the formula for the triangle would be half into height is 24 minus 6 into the base is 18 minus 0. So it is nothing but 18 square upon 2. okay, which is going to come out as 162. Okay, okay. Now, what is the tariff? We can directly calculate the tariff now. The tariff is consumer surplus plus P into Q. 162 plus what is price? 6. What is Q? 18. 6 into 18 is going to be coming out as what? So this is 108. So the total is 270. Okay, all right. This is your tariff. This is not your profit. This is your tariff. Now let us see what the profit is. The formula for profit here in the single consumer case is the tariff minus the total cost. Total cost is nothing but the MC multiplied by quantity. MC is how much? 6. Quantity is how much? 18. Again we are going to get 108. So you can write 270 minus 108. Again we are going to be left with 162. Why? Because the price and the marginal cost were equal in this case, which is why the profit is the same as the consumer surplus in this case, which we have already seen by the graph that the consumer surplus is the profit. Okay, so this was your example. This is something that is very easy, right? Now we can move on. All right guys, now before we move on, what I want to do is to explain to you the logical intuition and the actual mechanism that is going on behind this numerical. Okay, and in the single consumer case and in the two-part tariff, really quickly let us try to break it down. What is happening is, first of all, let us take the example of an amusement park. Okay, an amusement park. So what is going on here is, let us say that for each of the rides there is a price. So what the park does is that they bring the price of each ride down to the marginal cost. Okay, they bring the price down to the marginal cost, which is something that we have seen in the perfect competition. Okay, so the price is so low that it is like literally only covering their marginal costs, their cost for each additional unit of output. That is where they set the price. Now what they do is that they see that at this price the consumer is going to be consuming the optimum amount of quantity, just like in the perfect competition. Why? Because their MC is a horizontal curve and the downward sloping demand curve is right here. So 18 is the optimum amount of output that the consumer is consuming. Okay, so they reach the equilibrium. So now what they see is, they see that the consumer is getting maximum consumer surplus. Okay, they maximize the consumer surplus. That is the first step. And why are they trying to maximize the surplus of the consumer? Wouldn't that put them into loss? No. What they are doing is that once they have seen what the actual consumer surplus is, once they have like taken into account and they have calculated the total consumer surplus for each of the consumers, they put an entry fees that is equal to the consumer surplus. Okay, so now when the consumer has already paid the entry fees, when he goes in and he takes each of the rides at the minimum cost, which is like at the marginal cost, which is a very low price, he feels satisfied. He thinks that he is getting these rides for very cheap, but he doesn't know that he has already paid his entire consumer surplus in the fees at the very gate. Okay, so for example, you would see even in the OTT platforms nowadays, for like for example, like in Prime, you will see that nowadays in Amazon Prime there is a charge for each of the movies, also for some of the movies. So first you have to pay the subscription fees, then to watch a movie you have to rent it or you have to pay for the movie. That is a separate cost. Okay, so that is a similar functionality to this, that first you make the consumer believe that he is paying the the minimum prices, the prices which only cover the cost. So those are very low, and then you charge an entry fee extracting all of the consumer surplus. Okay, and how do you do that? You do that in this fashion. You know the maximum willingness to pay that the consumer has, and then you calculate the area of this triangle. That is what is really going on in here. That is what the two-part tariff means. Okay, that is why the entry fee is so important in this case. And this is a very realistic case as well. You will see this, you will see a lot of real life examples on this method. Okay, so now we can move on to the two consumers. Okay, so now let us move on to the two consumers in two-part tariff. All right, now we are talking about the case where there are two consumers in two-part tariff. We already know that the two-part tariff, the formula for the two-part tariff is going to remain the same, which is the consumer surplus plus price into quantity, out of which the consumer surplus is the entry fee, the price into quantity is the payment or the money that the consumer is paying for utilizing the services, that is the per unit price of that. Okay, so now let us see what happens here. The first case is the OI tariff. The OI tariff. Okay, what happens here? The goal here, let us first write it down. The goal here is to charge entry fee equal to the consumer surplus of the less willing customer. Okay, which means the less willing customer means the customer with the demand curve closer to the origin. What does this mean? What does this mean? This means that suppose you have a horizontal MC and you have two downward sloping demand curves for two of the customers. So suppose you have these two quantities. Okay, so if you put the entry fees equal to the consumer surplus of the second customer, of the customer with the higher demand, okay, who has more quantity demanded and the higher demand curve, what is going to happen? The entry fee is going to be this whole area. Okay, then what is going to be the issue? The issue is going to be that this customer who has only this much of demand, he is going to go away. He will not pay the entry fees because his consumer surplus is only this much, right? So what you are doing is that you are extracting all of his consumer surplus and even then charging him some more. So his willingness to pay is only till here. That is the maximum amount that he is willing to pay, right? So that is why you cannot charge the first customer this entire amount. Okay, so that is why this cannot be the entry fee, because the entry fee has to be the same for all the customers, right? You cannot have different entry fees for different customers based on their willingness to pay. So that has to be the same. So what you are going to do is that the two customers that you had, you are going to be charging the entry fee as the consumer surplus of the less willing customer who has the lower demand curve, whose demand curve is closer to the origin. That is how you find out graphically that this customer has lesser demand. Okay, because you do not want to chase him away, you want him also. So whoever has the least consumer surplus or the least demand, that is going to be the entry fees that you charge for every other customer. That is how you decide the entry fees. Okay, in the OI tariff method. Okay, either this method is going to be mentioned to you in the question directly with the name, or this methodology will be mentioned to you. Okay, so either ways you have to solve it this way if it is mentioned. So now let us do a numerical. Now let us do a numerical so that you are going to understand better. This is your example. The quantity one, because there are two customers in this case, both of them have a different demand curve. So we are going to have two different quantity equations. The first one is Q1 is equal to 24 minus P1. For the second consumer, we have the Q2 is equal to 24 minus 2P2, and the marginal cost is obviously going to be the same for both, which is just the cost of producing one additional output at 6 rupees. So what was the first step? What was the first step? Can you tell me the first step? The first step is still going to be the same. You are going to equate price and marginal cost for each of the customers. Okay, because we are charging at the minimal price. We cannot go below this. Otherwise, we are going to face losses. So we are charging at price is equal to marginal cost. Marginal cost is at 6. It is a constant cost. We have two demand curves that are downward sloping. Now let us first, what we are going to do is we are going to find the values. So at Q1, if let us draw two tables for both Q2 and Q1, right? Okay, so if Q1 is 0, P1 is 24. If P1 is 0, Q1 is 24. So now let us do it the same for the second one. If if P2 is 0, Q2 is 24. But if Q2 is 0, P2 is 12. Okay, P2 is 12. So what you are going to notice is that, let me draw the graph in a bigger area. Okay, I'll take the next page to draw the graph. This is 24 and what else? 24, and at the half point we have 12. Okay, so this is price, this is quantity. So our first demand curve is this, and our second demand curve is this. Okay, right? So these are the two demand curves. The demand curve that is higher is for the first customer. Now what we are doing is, at the price of 6, we draw our marginal cost curve. So when price is equal to MC, those are the two equilibrium points. So obviously you can see that the lower demand curve, the one that is closer to the origin, will fetch you a lower quantity, and let us find out what that quantity is going to be. When 24 minus Q1 is equal to 6, then Q1 is 18, Q1 star. Similarly, when what will be P2 in this case? It is 24 minus Q2 upon 2. Okay, that is P2. So if for this to be equal to 6, you will get that Q2 star is equal to 12. Okay, so Q2 star, this is 12, this is 18. Okay, and we have already seen that our consumer surplus has to be the consumer surplus, or our entry fee has to be the consumer surplus of the less willing consumer, and the less willing consumer here is the one with the lower quantity demanded, which means the second customer, and this is his consumer surplus. This is his consumer surplus. So let us write down here, consumer surplus 2, or of the second consumer, is 1 by 2 into 12 minus 6 into what is the base? It is 12 minus 0, so 12. So that is going to give you 3 into 12, which is 36 is your entry fees. Entry fee. Now you can calculate the tariffs of both the customers. It is going to be, for the first one, it is going to be, the entry fee is going to be same for every customer, 36 plus P1 Q1, right? We know that it is price into quantity, the total revenue that was generated by the customer inside the amusement park or wherever he was. Okay, so P1 Q1 is what? P1 is Q1 is 18, and you can also calculate P1 from here. It is 6. So 6 into 18. Similarly, the tariff for the second customer is 36 again, plus P2 Q2. What is P2? P2 is right, so 12, and that is 6. Okay, so the prices were obviously equal to the marginal cost, so you could have seen that from there also. 6 into 12, right? So that is 108, that is 144, and this is going to be 72, so this is 108, right? Very easy. You can also find the total cost. Total cost is what? Cost into total quantity, Q1 plus Q2. 6 into how much is your Q1? It is 18 plus 12, so into 30. Total quantity is 30, right? 30 into 6 is 180. So your profit is going to be the tariff you got from one and from second minus total cost. So that is 108 plus 144, which is about 252 minus 180. So that comes down to 72 is the profit. Okay, 72 is the profit. Now there is one more method that you can directly calculate the profit if nothing else is asked and only the profit is asked in the question. That another method that you can use to calculate the profit is that profit is equal to consumer surplus multiplied by the number of customers. Suppose you get a trick question where there are more than two consumers and it is directly asked to just calculate the profit. You can just write the profit is the consumer surplus multiplied by number of customers. So the consumer surplus was 36 into 2, which is 72, which is going to give us the exact same answer, right? It is going to give us the exact same answer. Okay, very easy, right? This was the OI tariff method, and the logical intuition behind this one also was the same as the single consumer case. It will remain the same in the two-part tariff case. The only difference here was that we charge the consumer surplus of the lesser willing customer so that we do not chase him away, right? Now let us do the final case in the second degree price discrimination, which is going to be the optimum tariff or the profit maximizing tariff case. Optimum tariff, right? Or another way you can write this as is profit maximizing tariff. Okay, this is another way to write it. So when we are talking about profit maximizing tariff, there is going to be a difference from the OI tariff case. Okay, in the OI tariff case, you saw that what we were essentially doing was we were multiplying the price 1 and quantity 1 and adding that to the entry fees. And the entry fees was the consumer surplus of the less willing consumer. Now, the entry fees is going to be the same. Entry fee is going to be the same. Tariff of 1. Okay, so entry fee is going to be the same, which is nothing but the consumer surplus. But what you are going to add is going to be slightly different. Can you notice the difference? Can you notice the difference between this and what we just did? Can you notice the difference or not? The difference is that we are not taking price 1 and price 2 anymore. What we are doing is that we are using a constant price P, which is greater than marginal cost, to maximize the profit. Okay, in the OI tariff case, what we were doing was that the price was just equal to the marginal cost. Now we are putting the price above the marginal cost and we have to set it at such a level where we are maximizing our profits. So we want to find the price Okay, what we are looking for now is not the profit. First, we want to find the price that is going to maximize our profit. Calculating the profit will be at the end. Right now, we just want that level of price. So that will, so you have done this before also. What do we do for this? We just write the formula for profit, and if we want to find the price, we are going to we are going to partially differentiate or find the partial derivative with respect to p, and that is how we are going to find the price, right? Equating the whole thing to zero. So now let us write profit. What is the profit? The profit is the sum of both the tariffs minus the total cost. So you can just write, you can write consumer surplus as A, then you can write this, right? This is the total revenue from first, then again A plus PQ2, this is from second, minus cost into Q1 plus Q2, cost into the total quantity. Now if you just add this up, you are going to write it as 2A plus, you can write it as 2A plus P minus C into Q1 plus Q2, other because the Q1 plus Q2 will be taken out common. So this is the entry fee, which is nothing but the consumer surplus. This is the markup. The markup is nothing but the price minus cost. We have seen this in the learner's index also, that it is the difference between price and cost. How much above the marginal cost are you setting your price? That is your markup. And this is nothing but the total quantity. So this is going to be your formula for the profit maximizing tariff case. Okay. Now let us take a small example so that you get a better understanding of it. Write down that Q1 is given as 24 minus P1. Q2 is given as 24 minus 2 P2. This is the same example that we did in the OI tariff case. We are just trying to find if there is any discrepancy between OI tariff and this case. If the profit maximizing case fetches us a different result or not. Okay, that is what we are trying to see here. So this time we are saying that the price 1 and the price 2 is equal to a price P which is set at a level above the marginal cost. It is greater than the marginal cost. So if you were to draw the diagram, how do you think it is going to look like? Last time we saw that this was 24. This began at 12 and it ended at 24, right? This was the graph last time, 12 and this was 24, and we had marginal cost somewhere right here at the level of 6. What we are saying now is that we set a price somewhere above the marginal cost. We do not know what this price is yet, but this is what we are going to be finding. And because the price is now higher, the consumer surplus is lesser. There is a drop in the entry fees. Earlier it was this triangle, the whole consumer surplus, because the price was at marginal cost. But now because the price has increased, this smaller triangle is going to be the consumer surplus of the lesser willing customer. We still go after the lesser willing customer. We still do not want to chase him away. We are just charging a lesser entry fees. Okay, the entry fees that we are charging has fallen. Now let us see if this entire practice or this whole exercise fetches us a different result, or was this all pointless. First of all, we want to find this point, right? I'm sorry. Let us try to add. We are going to go step by step, right? Because this is like actually a very confusing thing, that which step is going to come first, right? Because you have to maximize your speed also, and you have to maximize your clarity right now. Speed and all you can set according to yourself later on. So the first thing that we do is we find the total quantity. Q1 plus Q2 is 48 minus 3P, because P1 is equal to P2. Okay, now you can just find the consumer surplus. How much is that? 12 minus P is the height, and the base is how much? what is going to be this value? Okay, so you don't have to find this value. And the reason you don't have to find this value is because we are trying to get the entire equation in terms of P. And this is what? This is nothing but the quantity of 2 of the second customer, right? We have already seen this. And the quantity of second customer is already given. So you don't have to find the actual value. We do not want Q2 star right now. The Q2 is going to suffice for us right now. We know that that is the base. Whatever value Q2 star takes, it is still going to be in the form of the equation of Q2. So it is 24 minus 2P2. And this can be simplified as, if you just take 2 common out from this, this can be 12 minus P into 12 minus P into 2. So that is just 12 minus P whole square. This is the consumer surplus, right? Consumer surplus of the second consumer, which is the entry fee. Now you can write down the profit. Profit is, what did we find out? Profit was 2A plus P minus C into total quantity. Now what we are trying to do is to write all of this in the form of P. So 2A can be written in the form of 12 minus P square into 2. Then you write price minus the cost was 6, right? It was 6, and total quantity we have already found out, it is 48 minus 3P. So this is your equation in terms of P. Now we find the partial derivative with respect to P. So this is going to be 4, 12 minus P, or rather this is going to be minus 4, because the P has a negative sign. Plus you can just find the thing here, that is 48 minus 3P plus P minus 6 into minus 3. You are going to be equating this to 0. Now you can just solve this very easy. You can just write minus 48 plus 4P plus 48 minus 3P minus 3P plus 18 is equal to 0. P minus 2P minus 2P is equal to minus 18. P is equal to 9. Your profit maximizing price came out to be 9. Okay, this value in the graph, this value came out to be 9. Now we just put 9 in the whole profit equation that we had. Wherever you had P, just replace that with 9. So you can write this as profit is equal to 2 into 12 minus 9, 3 square, plus 9 minus 6 is 3, into 48 minus 27 into 21. That is it, right? So this is going to be 18 plus 63. That is going to be coming out as okay, 81. Your profit from the profit maximizing method, where we took a price greater than MC, right? Your profit came out to be 81 in the exact same question, and in the OI tariff method it was 72. It was 72 when you were charging a higher consumer surplus or a higher entry fee, which was the entire consumer surplus, and what you were doing was you were charging price equal to the marginal cost. But now when you charge a higher price and your entry fee is smaller, you are getting more profit, okay? So that is something that you can write down, that the profits gained with a smaller entry fee and higher price is more than with a higher entry fee and when a smaller price, and in bracket you can write when P was equal to MC. Okay, so when P is greater than MC, you are gaining more profits. The profit that you are getting is higher. Alright, so this was the example that I wanted to do with you. This ends our discussion for the second degree price discrimination. Now we can move on to the final case, which is the third degree price discrimination.